Now we shall again see one more problem which is just an extension of the previous problem. We have to count the number of A's and number of B's. Previously we did for mod 2 and mod 3. Let us say I have to draw a DFA. I have to construct a minimal DFA which accepts set of all strings over A comma B such that number of A's in W is congruent to 0 mod 3, which means number of A's is divisible by 3 and number of B's in B is congruent to 0 mod 3, which means number of B's is also divisible by 3. So number of A's is divisible by 3 and number of B's is divisible. From the problem description you can understand that the number of states in the final answer has to be 3 into 3, which is 9. And I will be using the same method like counting the number of A's horizontally and number of B's vertically. So let me count number of A's. So the A counter is nothing but mod 3 counter. So A which is mod 3 counter, and now B has to be again a mod 3 counter. B and B. So again repeat A mod 3 counter for A, mod 3 counter for A, mod 3 counter for B, mod 3 counter for B. So it is going to be A for A. Okay, again A counter, mod 3 counter for A. Again B. So now you see this, it is nothing but horizontally we have counted the number of A's and vertically we have counted the number of B's. Mod 3 counter for A, mod 3 counter for B, mod 3 counter for A, mod 3 counter for B, mod 3, like that. So let's see what does each state denote in this question. What is the relevance of each state? Now the first state is this one. Definitely it is going to have 0 A's and 0 B's. See, without seeing anything, you can directly write it like this and then we can even analyze it. 0 A's, 0 B's. And this one is going to be 1 A, 0 B's. This one is going to be 2 A's, 0 B's. Why? Because now to reach this state, I have seen only 1 A and 0 B's. I have seen only 2 A's and 0 B's. And if I have to reach this one, I have to see 1 B. Therefore, and A's are 0. 0 A's, 1 B, and then 2 B's. 0 A's, 2 B's. Right? And if I have to reach this one, I have to go with 1 A, 1 B. If I have to reach this one, I have to go with 2 A's, 1 B. If I have to come to this state, I have to go with 1 A and 2 B's. If I have to reach this one, I have to go with 2 A's, 2 B's. 2 A's, 2 B's. Right? And after writing these numbers, actually these numbers are nothing but number of A's when divided with 3. It is nothing but number of A's mod 3, number of B's mod 3. You can check it later. Okay. So now the question is, they have asked us that number of A's should be divisible by 3 and number of B's should be divisible by 3. Therefore, for this question, the answer is 0, 0. The final state is 0, 0. Right? And they can ask many other kinds of questions. Let us say the question is this. Number of A's in the string mod 3 is equal to 1 and number of B's in the string mod 3 is equal to 2. Then in this case the final state is going to be 1, 2. The final state is going to be 1, 2, this one, not 0, 0. Or they can even compare number of A's and number of B's mod 3, which means number of A's in the word mod 3, let us say, has to be greater than number of b's in the word mod 3. B's in the word mod 3, which means number of a's has to be greater than number of b's. So where is number of a's and number of b's? First one is number of a's, second one is number of b's. Let us check for all the states in which first number is greater than second number. One state is 1 0. Why? Number of a's is greater than number of b's, mod 3. And other one is 2 0. Why? Because number of a's is greater than number of b's, and another is 2 1. Right? So these are the only states where number of a's is greater than number of b's. And sometimes they can even ask the same question, number of a's and number of b's comparison. Since both are mod 3, they can pull that mod 3 out. That is called modular arithmetic. According to modular arithmetic, it can even be asked like this: number of a's mod 3 is greater than, number of a's is greater than number of b's, and for entire thing they can put mod 3. Even for it, the same answer will be applied. Right? So you can use your imagination and you can extend this question to any level. So the number of states will depend on the mod numbers, and the number of and the final state will depend on exactly what they are asking. Just draw the diagram using the number of states and then the number of the states according to number of a's and number of b's, and then choose the correct state using the question. Right? So if the question is, let us say, number of a's is congruent to 0 mod n. In fact, it can be any number, don't worry about it. And number of b's in W is congruent to some 0 mod m. Then the number of states in the automata is going to be m by n, or m into n. So this is the minimum number of states in a finite automata which counts number of a's mod n and number of b's mod n. So you can extend this question to any level using your imagination. I am going to stop it here.